I want to represent an atom of the iodine. So how can I do that, Bruce?
I.
Just plain I. Okay? Well, of course then, if iodine is I, what do you do for iron? Fe, exactly. Those are two that are easy to confuse. So if you just write the symbol, then that represents an atom of it for the time being. But now, I want to get a molecule of that stuff. So, Madeline, can you tell me how I represent a molecule? This, I'll stall while you're thinking. I will talk. Remember, when you're talking about elements, some of those guys up there are diatomic and some are monatomic, and the only way to know is pay your dues, memorize the list. Remember that. I bring play for our new house business. Okay, Madeline, did that give you time to think?
It's diatomic.
Okay, so you would write diatomic. Di means what? It means the same as bi, which means two. So tell me how to write this. Two in front or two behind? Nina, help her out. Two. After subject. Exactly. I2. Not two in front. If you put a two in front, you would be saying two iodine atoms. But if you put a subscript, you mean two of those guys have come together, because to be a molecule, you have to be able to exist independently. In other words, you're stable. Iodine atoms are not stable. And you'll learn more about why they're not stable later. So, when you talk about putting iodine on a cut, first of all, at room temperature, iodine will be a solid. So what you're buying in a pharmacy is actually a solution, usually an alcohol solution. The iodine crystals have dissolved. You're not putting iodine atoms on yourself, you're putting I2 on yourself. Nina?
So if the two's in front, then they may or may not be stable?
Okay,
There's just two of them.
if you put 2I, thinking it was the same as this, no. If you put a 2 out front, it means two of those guys, two atoms of it. They're off by themselves, wouldn't be stable. They're going to come together, and they're going to be sharing some electrons, and it forms I2, which means this is a unit. Okay? So this could be represented, as your book does, a circle. This would be represented something like that, okay, with nucleus and nucleus. And this would be represented like that, if you like visual stuff. Okay? All right, naphthalene, which you all smelled, and somebody guessed, I think, what that was. So, Nikki, can I show an atom of that?
No.
Okay, why not?
Because I forgot why not, but I know it's no.
Okay, you know. Okay, so, okay.
I think it's because you can't show an atom when there's two atoms.
It's a compound.
Yeah, it's a compound.
It's a compound. The word atom only applies to elements. So you can never talk about an atom of some compound. Okay, but, Nikki, before I let you off the hook, how would we represent a molecule of naphthalene? Okay, this is, so you want to be a millionaire. Ask a buddy around you, or point at a buddy to have to answer this.
Oh, God.
Even if it's a friend, that's okay. She or he won't. Ask for help. Liz is right there.
I know.
Liz, take it.
What was the question again?
Oh. Okay, I want to represent a molecule of that naphthalene. I can't represent an atom. We finally went through that painful process. So, Liz, how would I represent a molecule of it?
Would it still be I'm not sure if I'm correct, but the same as what you have on there?
Precisely. Like so. Okay. Now, if you did this, let's get back to this coefficient problem. If you write a 2 out in front of this, it means you got two molecules of naphthalene. Here we just want to represent a molecule of it, so we have to use those same things. Okay, Allison, what's an atom of this stuff? Can we do it?
No.
No. But what's a molecule of this stuff, Allison?
C6H12O6.
glucose. Now, that's not the sugar on your table at home. Sucrose is table sugar at home. Glucose is a simpler sugar. It's sometimes called blood sugar, sometimes called grape sugar, I think. That's, if you don't get enough to your brain, that's when you start not being able to concentrate. So at break time, you run out and have a candy bar, take a hit of sugar, and the sucrose you eat, our bodies break it down and give you some glucose for the brain so you can think more clearly. So sugar isn't necessarily bad. We need it. So this is glucose, simpler sugar. Okay, arsenic. Arsenic right here, and I'm cheap because I got my sheet right here. Marco, tell me what arsenic is.
Arsenic, okay. It's
What's this? Can I show an atom of arsenic?
not.
Yes. Yeah.
Okay, your friends are saying yes. Is it an element?
Yes.
Yeah,
Yes.
it's an element. So, Marco, you know the symbol for it?
No.
Who does know the symbol?
Yes.
Yes. Okay, notice there, what have they done? They're not using the first two letters, because look how I spelled arsenic, A-R. Okay, but it's a second letter, is one you hear when you say it, arsenic. Okay, so A-S. And I passed some of that around last time. That was the element, arsenic. Okay, like Arsenic and Old Lakes, that movie where little old ladies were poisoning people. They weren't using the element arsenic, they were using well, if they really, it's a play, I mean, so it's fiction, let's hope. But if you were really killing people, and I'm not advocating that in case you're recording me over there, okay, you don't use the element, you use a compound of it, so it's sure soluble in the body. Because if it's not soluble in the body, our bodies don't absorb it. So you could swallow a poison, and if it just passes through, it's not going to hurt you. Okay, unless it's, you know, edges or something and cuts the intestinal tract or something. But if you don't absorb it, meaning it's got to dissolve either in your stomach or your small intestine, and if it doesn't do that, it's not going to hurt you. So those lumps of arsenic you saw, I'm sure that's not what the little old ladies were using to kill their gentlemen callers, okay, and bury them in the backyard. If you haven't seen that movie or that play. Okay, so this is an atom of arsenic. Okay, now, we want to show a molecule of arsenic. Emily, can you do it?
It would just be AS, wouldn't it?
Yes. Because it's what? What's the word for it? Monatomic, exactly. Okay, now let's get over to here and let's see if we can pick up the speed a little bit for these problems.
That's all right.
Yeah.
The diatomic was what you showed us.
Okay, diatomic. Okay, give me a family name. 7A. The entire 7A family is diatomic, plus 3 others. Let's hear one of them. Nitrogen, oxygen, and hydrogen. Okay, and what I did in class, diatomic, need to know. Okay, I bring clay for our new house. Those are the diatomics, and we're going to assume everything else is monatomic. Okay, now